So today we're doing a Leetcode problem here. It says called house robber. So let's read the prompt here. It says, you're a professional robber planning to rob a house along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each house is that the adjacent houses have security systems connected and will automatically contact the police if two adjacent houses are broken into at the same night. Given an array of integers nums representing the amount of money at each house, return the maximum amount of money you can rob in one night without alerting the police. Okay, so we're given this array here that says 1, 2, 3, and 1, and the output is 4. And the explanation says you rob house 1 that has money equal to 1, and then we rob house 3. And the total is 3 plus 1, which gives us the 4. So we can't rob this house at 2 because we robbed the house at 1. And since this 1 and 2 are adjacent to each other, we have to skip this 2. Okay. That's pretty interesting. Okay, this looks, we could easily solve this with recursion, just calculating all the possibilities here. And if you want to do that method, we would have to return a DFS function. I'll create it in a second. Give it our nums array, and then the index we want to start out. For now, we'll just start at 0. And then we'll say int DFS, take in our vector of integers and our index. And what we're going to do is, let's say we'll make our base case here and say if the index is greater than or equal to the nums.size, then we'll just return 0, which means we've went to the end of the array and we calculated everything we need to calculate. And then we can just run our DFS recursively, but of course we want to find the maximum. We're just going to return the maximum of our DFS function, giving it the nums and the index, plus 2, and we're plussing 2 because we cannot access our index right next to it, which would be plus 1. So if we start it from index 0 here, we have to increment it by 2 to see our next option here. But we also have another option. Say we start at 0, we don't have to go to this index 2 right here. We can also go to this index 3, so we're gonna actually have to calculate 2 different paths, which would mean we have to find the maximum between 2 different recursive calls. So if we call this again with nums of DFS starting at 1 instead of 0 and get the maximum of that, that should calculate the 2 different paths and return whatever path is most beneficial. So right here we're returning the maximum DFS, giving it the nums and index plus 2, and our DFS function giving nums and index plus 3 for that other path. Okay, is that it? Might be it. So what's happening here? So we have our nums array. We're returning the maximum of 2 different paths, and it's going to the end of the array, and then this returns the maximum of the plus 2 path and the plus 3 paths. Okay, let me run it and see what happens. Okay, we got zeros wrong. What seems to happen here? Oh, my bad. Okay, so I forgot we actually need the values of the current index. So we need the maximum of the nums at the index plus the DFS function that will return the maximum of the path, right? So the nums at index plus this. And that's what we need to find the maximum of. So if we submit this, yeah, now it works. Now, the time complexity is exponential, which is something we're definitely going to have to improve on. So if we want to improve on this very simply, we could just create either a two-dimensional array or a map. I'll just do a map because it's simpler. So I'll make an unordered map here of string values to integer values and call it DP. And then we need to create a key that will be our string. So I'll just say string key, and I'll set it equal to the nums at the index, but we need to turn this into a string so we don't get an error. So toString plus, make it unique with a comma in between, and then toString version of the index. And this needs to go on top of this, or else we'll get out of bounds since we're incrementing the index, and this checks that the index is in bounds. That makes sure that this won't run an error. Right, and then we return the maximum key, and then we need another if statement right here that checks if, say, the dp.find the key value is inside of the dp.end, so it's in the map, we just return the dp of the key value. Just like that. And then right here we can just say dp of key will equal the maximum of that, so that should store the value in our DP key, so we can remember it for the next time we ever make duplicates of that calculations. If you haven't seen my videos covering memoization, I think it's a whiteboard or a chalkboard, a down chalkboard, but definitely watch that if you're confused about what I'm doing right now. And then I believe that should memorize it. Map. All right, let me run it and make sure we didn't do any syntactical errors. Okay, we're good here. And then this should run significantly faster. Definitely polynomial time. So we submit it. All right, and it worked.